Okay, so I'm talking about basically a full, let's say, GitOps CI/CD pipeline using Tekton and ArgoCD. So just a short reminder, GitOps. So GitOps, in my opinion, is operations by pull requests. In other words, so we are basically extending the concept of infrastructure as code and pipelines as code, and of course, code on top of Git repositories to everything. And why do we need this additional concept? Basically, in my opinion, the main reason is Kubernetes. So Kubernetes is the de facto standard for orchestrating containers. And we are kind of, so by the, let's say, time, we are switching from an imperative way of doing things to a more declarative way of doing things. So in an imperative way, you say how you want to do something. In a declarative way, basically, you say what you want to achieve, and something, for instance, Kubernetes, is going to take care of it. What are the advantages of using GitOps? So in my opinion, like the first advantages I see, but for sure there are many others. So we have some kind of basic disaster recovery strategy. We have some auditing, who did what, when, and so on. We have rollbacks. So we can just roll back a commit, and that's it. And we can have code reviews for everything, including infrastructure, installation of middleware, configuration, applications which are deployed, and so on. And the tool, which is a member of CNCF, the tool which is pretty common nowadays is ArgoCD. Basically, ArgoCD allows us to, let's say, to reconcile state from a Git repository into our cluster or clusters. Now, what about CI? We know that CI is super important because as developers, we don't write the perfect code straight away. Coding is a sequence of super tiny experiments. And since we work in an agile way, we want feedback as soon as possible. So as stated, let's say also in the extreme programming principles, we need to give feedback as soon as possible. And we use CI. Now, how does a normal project look like? What I see by the customers. Everyone is agile, everyone is doing CI, yeah. But actually, it looks like war normally. So you see smoke, you see gunfire, people screaming, fighting. And if you check in the bottom left corner, you can see even the project manager, which are dead. Poor them. Okay, let's take a step back here. So how do we do CI, and also in the, let's say, cloud native area, and in this presentation as well, we will use Tekton. So the first Kubernetes native pipeline execution engine, which has basically pipelines, allows us to define pipelines, as we all know, which are cloud native, since they are based basically on containers, and which are decoupled, because we have different building blocks, which we can combine to create advanced pipelines. Okay, so we said ArgoCD for doing continuous delivery, and Tekton. So let's try to combine these two, because what I have seen right now are normally either examples using just Argo, other examples using Tekton, but nothing really super, let's say, nothing advanced, nothing really cloud native. So my idea was to create a GitOps CI/CD pipeline, which combines those tools, Argo and Tekton. So what's my goal? And I will try to show you everything now in the demo. My goal is to build, test, and of course, deploy a simple Spring Boot application. So we will have two Git repositories. The first, of course, is the, let's say, the microservice repository. The second one is a GitOps repository. So at the moment, we have just one GitOps repo, which is kind of, let's say, is getting bigger. In the future, we might have more than one. But what's the goal of a GitOps repo. We represent everything on a Git repository, starting from the configuration, infrastructure, middleware, which is running on top of the cluster. Could be a message broker, Kafka, could be the Istio service mesh, could be Tekton itself, and also the applications. Yeah, stop with the boring stuff. So let's try to have the demo. So I think, yeah, you're all still here. Let me switch now to, I will go to my browser. I hope you still see everything. Okay, so everything is on my GitHub, by the way. So if you just check on my GitHub with Paolo Carta, where you will find that also the two repos which we are going to be using today. The first one, as I said, is a microservice written with Spring Boot, which is super simple and has also a few tags. We will discuss them later. Second repository, we said the GitOps repository, still on my GitHub. It's called OCP, so OpenShift Container Platform GitOps CI/CD pipeline, and has a few things as well. Okay, so we will examine the content of the repositories, of course. Now, I do have also an installation of OpenShift, which is running on AWS at the moment. And what do we have? Okay, so let's discuss the setup. We said we have basically 2 repositories. That's it. Now, what's on top of the cluster? On top of the cluster, of course, everything managed using GitOps, we have a namespace. So a project for ArgoCD. On top of, let's say, of this project namespace, we have the ArgoCD operator to manage Argo. And of course, as you can see, we have a bunch of pods here with the Argo installation. Let me close this. Okay, then what do we have? We have, of course, since we are using Tekton, we have, let me search the OpenShift pipelines. Of course, we have the OpenShift pipelines also project, which is running a bunch of controllers which are necessary for Tekton. Everything, of course, is installed, again, using the operator and following a full GitOps approach. What does it mean? So everything you see now on the cluster, Argo, Tekton, is installed by Argo itself and is represented in the GitOps repo. One more thing. I assumed now, since we have an application and a CI/CD pipeline, I assumed we have a developer team. In my opinion, a cross-functional team, so a real DevOps, so DevOps team, because DevOps is, we know, is not a role, it's not a job role, is a culture. So for this developer team, I created 3 projects. One for running CI/CD pipelines. You can see that now. At the moment, there is just one super simple pod, which is basically a listener. So listening for webhooks from GitHub. Now, this team has a staging repository. As you can see, we do have the Spring Boot microservice running, an old version. We will update it. And we have production. As you can see, again, we have the Spring Boot microservice. In this case, since we are production, we have more pods. We need more capacity. Okay, so this is the setup on OpenShift. Let's jump for a second on ArgoCD. So as you can see, Argo has a really nice interface. Of course, I have a lot of applications here. Let's focus on what's important for us. Developer team. Let me filter. Okay, let me make it a little bit bigger. So now, what do you see? We are using GitOps, we said, and we see the Spring Boot microservice running for staging on the right-hand side and left-hand side production. we can inspect, for instance, what's running on staging. We have a bunch of things. And if we check in the details, we see, for instance, that we are running the basic Spring Boot microservice version 1.2.17. Okay. Of course, we have a few more things in Argo. For instance, we represent also the CI/CD using GitOps. And as you can see, the CI/CD is also basically a bunch of Kubernetes manifests. Actually, here it will be an Helm chart. So CI/CD is also represented here and handled by ArgoCD. So whenever we update the pipe, this is going to be automatically synced by Argo. Of course, so this is what's important for us, the application and the pipeline. Of course, as you can see, we have a lot more. And just one more thing. So let's check the bootstrap. So this is what's important for us. So as I said, Argo, now the idea I'm using here for this presentation, which I think it's interesting, it's innovative, it's using GitOps also to manage the GitOps tool. So we are using GitOps to manage Argo itself. So if I want to update Argo, I change a manifest in a Git repo, and Argo is going to update itself. Then we have a Bootstrap application. So a Bootstrap application is like a tree of nodes in which it allows us to bootstrap a bunch of applications. So we can bootstrap, let's say, 100 applications at the same time. Let's say I add a new application. This is automatically added and deployed. So that's the idea of the Bootstrap, which I'm applying in this presentation. But now, too much boring stuff. So let's trigger the pipeline. How do we trigger the pipeline? We said we have a microservice, and we want to trigger the pipe. In order to do that, I just created, a super stupid, let's say, super dummy file. Let's say new commit for, and let's commit this stuff. So in order not to switch, I will just now stay on VS Code. Let's say dummy commit. Okay. And let's try to push it. Hopefully the network is with me. Okay, so this one, let's check. Otherwise, we'll do that in another way. So my idea now is pushing to the repo so that we can trigger the Tekton pipe. Let's check on GitHub if my commit was successful. So dummy commit 31 seconds ago. Wow, the demo gods are with me till now. Okay, so let's check OpenShift now. So we said we have a developer team. The developer team has a CI/CD namespace. Nice. We should see a pod, yeah, which is running now the pipe. Or at least, well, even better, a task within the pipe. And the pipe, wow, is running. So in the meanwhile, let's do something else. It will take 2-3 minutes. So let's jump now into the YAML definitions. Okay, let me close everything here. What do we have? Now, where are we, first of all? We are in the GitOps repo. The GitOps repo, as you can see, contains a bunch of folders. Because, of course, as I said, we installed everything using GitOps principles. But now, what's important for us? The important part is folder 5, applications. We have the Spring Boot microservice. Let's open it. Inside this folder, what do we have? We have, basically, a CI/CD Tekton pipe, first folder, which is actually an Helm chart. Okay. And then we have the manifest. So the deployment manifest for the application. As you can see, you will notice something familiar. We have 2 folders inside here. One is base and one is overlays. So you can imagine why we are using customize So with customize, we have a base, let's say deployment. Let's say that in the way, and two overlays for overriding special parameters on staging and production. Okay, let's start with our pipe. I will not cover everything because it's not the main focus is not explaining Tekton here. But let's go at least through the basics. So as you can see, it looks familiar. It's an Helm chart. So the Tekton pipeline is represented as an Helm chart. As well, we have a pipe, so kind pipeline, API version Tekton. Nice. We have, of course, well, a few workspaces and a few resources. What's important for us? The two Git repos. So we need to build the code. So this is the first repo, the microservice. And then we need, of course, to play with the GitOps repo within the Tekton pipeline, because Tekton now has to interact with Git in order to have a fully GitOps pipeline. Okay, so the pipeline includes 3 tasks. Task number 1. Task number 1 is a Maven and container build. Nothing super difficult here. Then, second task, as you can see now, I'm highlighting it, line 38. This is a deployment task. And you will see, we will dive deeper into that. This is a special task because it's not an imperative way of doing a deployment. Normally, you have seen OC apply, some -f, -k, something, or you have seen kubectl apply. No, we cannot do that anymore. We are using GitOps. So Tekton has to update with the GitOps repo using an SSH key, of course, associated to a Tekton bot account. Something important here, deployment to stage. You will see a parameter line 47 to 49. This is representing the folder which contains the manifest associated to our application. Okay, and as you can see, we are pointing to the staging overlay using the customize syntax. Third task, last but not the least, we need now, after updating the GitOps repo, we need to say to Argo, you need to sync the manifest which are in the Git repo, sync the manifest in the cluster. So we need to notify that. Okay, so let's go. Okay, we said we have 3 tasks within the pipe, right? Nice. The first task, Maven and container build. So as you can see, we call a step, which is Maven package. And don't tell anyone, we are using the flags -d skip tests. We are doing Jesus-driven development. So please, Jesus, help us. So now, okay, we shouldn't do that on production. I'm just doing that in order to be fast. You know, we have just 25 minutes, so I don't want to run the full test suite. Now, what I'm doing then, other steps, we have to compute that version because we need to produce a container image, and we are doing trunk-based development. What does it mean? We have a microservice, each commit on the master through a pull request to a direct commit is a potential release candidate. Has to go through the CI/CD pipeline, nice. And of course, we need some intelligence to say which version. So we need to automatically increase the semantic versioning. So this is the first step. Then we need to tag the repo. We need to build with builder. We need to build the container, push the container into the container registry. We need now to push the tag to the Git repo. And afterwards, we need to deploy. So let's switch now to the other task within the Tekton pipe. We have also here a few steps. First step, you will recognize we are using customize in order to increase the version. Okay. And in order to increase the version, we are using the output from the previous task, from a, let's say, from a file in some kind of exchange area. I'm using a container, an help container, which I built for the demo. I call that, so this is my Docker account, Docker Hub account, and I call that kickd. So it comes from CI/CD, but with K for Kubernetes. So it's an helper to do CI/CD, let's say, stuff. For instance, calculate semantic versioning, using customize and more, and Helm and something more. Now, we said we increase the version of the version which is deployed on Kubernetes OpenShift. We commit this stuff on the Git repo and we push. Then, after pushing to the GitOps repo, so we push the new version, we call Argo and we say, Argo, we need to sync. Nice. So let's check that I'm not cheating here. Okay, so this is OpenShift, just for the last few minutes. So the pipe completed, so starting 8 minutes ago. It's the duration about 4 minutes, but it's green, it's successful. So cool. So now if I go to staging, we will see the microservice running. Let me switch to the workloads. And which version? Let's check in the YAML. Sorry if I'm going too fast, but we don't have that much time. We can go in details if you stay later. So we said we had 1.2.17, and wow, now automatically, without doing anything, we have the basic Spring Boot microservice 1.2.18, which is up and running. Nice. So we have a container tagged with 1.2.18. Let's go to the GitHub repo for the microservice. Let me refresh. Let me go to the tags. And as you can see, 10 minutes ago, the Tekton bot has created a tag 1.2.18. It means now we know exactly which code is contained in the container image. Nice. Let's go to the GitOps repo. Again, let's refresh in order to close everything, and you will see a special commit here, done by a Tekton bot. As we said, we are using GitOps. So the Tekton bot had to update the GitOps repo. Let's check. As you can see, no cheating here. We switched from 1.2.17 to 1.2.18. So it means promotion. We are promoting using Git, everything on Git. We are promoting version 1.2.18 to staging. Yes, so that's it for the moment. If you have any question, so I will stay for another like 25 minutes. Thank you for the attention.
Thanks, Paolo. So Ed